Good morning. My name is Caitlin Green, and this is my textbook vlog over the Chapter 10 Textbook Problems. This is officially Part 2, and in Part 2 we'll be going over Problems 6 through 9. And in the first part we went over Problems 1 through 5, so make sure you check that out too. So in problem 6, it says a verbal discrimination experiment is done in which 30 randomly assigned subjects receive feedback of 0, 2, 4, 8, or 16 seconds after responding. The response measured is the number of trials to reach a learning criterion. It then tells us to test this null hypothesis in which mu0 is equal to mu2, which is equal to mu4, so on and so forth, with an alpha of 0.05. So just a couple of important pieces of information. We know that k is equal to 5, ng is equal to 6, and n is equal to 30. And I also went ahead and found the sum of x values as well as sum of x squared values for groups 0 through 16, and got a total value of 146 for the sum of x of the groups and a total of 832 for the sum of x squared of the groups. So with that information, I went and found the sum of squares total, which is, or looks like, the sum of x of group I and j squared minus the sum of x of I, j, and then parentheses squared divided by n. So it ended up looking like 832 minus 146 squared divided by 30 to get a sum of squares total of 121.47. I then went ahead and found the sum of squares groups because we were doing, or not because, but just because we're doing a between subjects ANOVA, and I found that value to be 72.8. And then I found the sum of squares with n, which is just simply taking 121.47 minus 72.8 to get a value of 48.67. I'll quickly show you what for that problem. And so I then need to make a source table, and I'll go ahead and read it as such. So for the G, I found a sum of squares to be 72.8 and the degrees of freedom to be 4. And then for the within group, I found a sum of squares to be 48.67 and the degrees of freedom to be 25. And then I found the MS value for G to be 18.2 and then within group to be 1.95. I then divided those two values to find the Fmax calculated of 9.3. Since I found all those values, I then just need to solve the hypothesis. So we have a null hypothesis of mu I is equal to mu j, which is just a simplification of the null hypothesis that the textbook gave us. And then I found an alternative hypothesis of mu I is not equal to mu j with an alpha of 0.01. And I found the Fmax calculated, like I said before, to be 9.3 with degrees of freedom of 4 and 25. And the Fmax critical to be 4.18 with degrees of freedom of 4 and 25. So the decision is to clearly reject HO and accept H1. And we have to do the quote-unquote English part in problem 7. It just says, in view of the outcome, I'm going to go ahead and scoot this down just to make it even with my paper, but it says, in view of the outcome of problem 6, describe what should be done next. So it says describe, not actually do. And so because I rejected HO in problem 6, I would then need to set up a LSD matrix to compare the differences between the means in order to determine significance, because of the fact that we rejected HO and accepted H1 in the previous problem. It then indicates that there is more work to be done. Now in problem 8, it says another version of the verbal discrimination experiment 8 subjects underwent all 3 feedback conditions only 0, 4, and 16 seconds. Again, the number of trials to a learning criterion was the response measured. And then it gives us a null hypothesis of mu0 is equal to mu4, is equal to mu16 with an alpha of 0.05. So they are related groups, so we'll be doing with a within subjects ANOVA. We know that K is 3 and NG is 8, and we know that we have a total number N to be 24. And because we're doing it within subjects ANOVA, we have to find the SI values of the subjects and their tests, and I'll briefly show you how I added on to my table, maybe. So as you can see, probably not doing a very good job, but you'll be able to see it better in my textbook problems. I just added across and then I added down to get a total value of 117. And so I then went to the sum of squares total, starting all those equations, and I took 711 minus 117, which is the total we got before, divided, or 117 squared divided by 24, and how we get those values is from the EX and the EX squared that I did as well. And I got a value of 140.63. I think I already said that though. I then did the sum of squares group, and we've done those before, and I got a value of 95.25. And then I took the sum of square S, which is very long to write. It basically is just taking all those SI values that I found before, squaring them, dividing them by 3, and then subtracting it from 117 squared divided by 24 to get a value of 22.63. And we now have a new error term, since we're doing it within subjects ANOVA, sum of squares of G times S. And that is basically just sum of squares total minus sum of squares G minus sum of squares S. So we're just going to take all those values that I found previously and subtract them to get an SSGX S of 22.75. I then need to make a source table, and it's pretty much the same setup as when we did the pairwise comparisons of between groups when we make a source table. This one's just a little bit more convoluted just because we have to add that in that new error term. And I found that for my G values, I ended up getting 95.25 for the sum of squares, degrees of freedom to be 2, and MS to be 47.63. For the S values, I got 22.63, 7, and 3.23. And for the GXS values, I got sum of squares to be 22.75, degrees of freedom to be 14, and MS to be 1.63. And to find the F calculated for this problem, we take G and divide it by GXS, and we get 29.31. And so now all that is left to do is to just go ahead and set up our hypotheses, and so we get mu I is equal to mu j for the null hypothesis, and for the alternative we get mu I is not equal to mu j. We have an alpha of 0.05, and we found our F calculated value to be 29.31 when degrees of freedom are 2 and 14. And our F critical value is very small in comparison at 3.74. So the very obvious decision is to reject HO and accept H1. And we find the English in the next problem, so I will come back to that after we do problem 9. And it says, if HO is rejected, compare the 3 means at alpha 0.05. So we're doing an LSD comparison. And this box is set up pretty simple, like the pairwise comparison, in that we have k minus 1 for the smallest, and then k minus 1 for the largest. And we got 2.38 and then 5 on one side, and then 5 and 7.25 on the top. And what we found is we actually had 3 significant values, and those significant values are both on the top row. We got 2.38, and 5 has a critical value of 2.62, and then we also find that 7.25 and 2.38 have a significant relationship at 4.87. And on the bottom row, 5 and 5 are not significant because it's the same number. And so we go on to the 7.25 and 5, and we get a significant value of 2.25. And to complete off this LSD comparison, we have to do the equation of LSD is equal to T sub alpha multiplied by the square root of 2 times MS, but in this case, GXS. Sorry, my mom's calling me. Divided by NG. And so it looks something like 2.145 multiplied by the square root of 2 times 1.63 divided by 8, and we get an LSD of 1.37. And with this value, we can now go back and further compare the values of number 9, and we actually find that the 3 significant values from before continue to be significant because all of those values are larger than 1.37. So after we've compared the 3 means in this LSD matrix, we can go back to problem 8 and complete the problem that in English on problem 8, the X group 4 was significantly more than the X group of 0. And the X group of 16 was significantly greater than the X group of, or excuse me, not X group, but X bar, the X bar of group 4 in both tests. So I'll show you what I mean by in both tests. As you can see here, on this value and this value, they were both significant for group 16, and that they were both larger. And then on the top row, group 4 was greater than group 0, but it was not greater than itself in the bottom row because 4 and 4 are not significantly different. So this has been my textbook vlog. I don't know why I keep saying it like that, but this has been my vlog over the Chapter 10 textbook problems. This is officially my last vlog of the semester, so pop a bottle of champagne and celebrate. But thank you so much for watching, and remember that these are 2-part videos, so don't forget to watch the other. Thank you so much, and have a good rest of the year, I guess. Bye.